welcome you to the 27th lecture of surface mining technology. We are continuing with excavation with shovel. This is the fourth lecture in this series, and in this lecture we will discuss the pit layout and we will discuss the cost analysis pertaining to the surface pertaining to the excavation with shovel, and let us have a glimpse of the learning background required for surface mining technology course, learning objective of surface mining technology course, learning outcomes expected from the participants of surface mining technology course, and these are the some of the textbooks and references of surface mining technology course. Apart from that, also a number of videos are available in YouTube, web sources are also there, please go through those things. And let us retrospect of the previous lectures. So far we have covered the phases of mining a deposit, and we have also discussed the unit operations pertaining to those phases and how the decision will be made after each phase, whether the mining will be carried out or not. We have also discussed the commencement of surface mining using a box cut, and we have discussed the unit operations like drilling and blasting, and we have also discussed the blast free technology, where the rock mass will be fragmented, and this is understood that the in situ rock mass which has to be mined has to be reduced in size, so that the material can be excavatable and material can be taken out by the excavator or transported to the where to the plant where it will be used. So, for that all this drilling, blasting, then loading and transportation is carried out. So, basically these are the sizing technique and material transportation technique which is practiced. We are discussing the excavation by shovel, and in this lecture series our objectives are understand the type and operation of the shovels, excavation principles of the shovels, and understand the cost and performance calculation. So, performance calculations we have carried out in the previous lecture. In this lecture we will understand the cost analysis of the shovel operations. So, most of the part is covered. In this lecture we are mainly eyeing on the understanding the cost of the cost analysis of the surface mining operations, but before that let us discuss something related to the pit layout. What could be the possible pit layouts where the surface mining has to be carried out, the best way it can be carried out. So, this is a example pit available, these are taken from the web sources. I have taken it from the lecture notes of Professor Pathak. So, this you can see where the shovels are under operations, and this is the drilling is carried out, this is the shovel which is taking out the material. So, basically this excavation is under progress like this. So, this excavation, this portion material will be excavated and the pit will be extended. So, the pit is being extended in this direction, this is also extended in this direction, this is also extended in this direction. You can see the extension is carried out in this direction. So, generally the pit extension is carried out, and accordingly our shovels are being deployed for the extending of the same. So, obviously, if we are considering a circular pit, this circular pits will be gradually extended in these directions, and this will be also gradually extended in these directions. So, this is the gradual extension, this will be extended in this direction. So, that in future this can be made like this. So, this is the way we are extending our pit, and as we are extending our pit, we are also changing the layouts of the pit, and for that our operation of the shovel is required. And for the benefit of the best operations of the shovel, we are basically designing our pit in such a way, so that excavation can be made easily. Now, there are few things which are essentially controlled during a designing a layout. First is the operating space. The space required, suppose in this case the shovel is loading at this position. So, as this position is kept for the operation of the shovel, then we have to provide sufficient space. Say this dumper is taking the material and coming in this way, and this is the next dumper which is waiting to take the material. So, these are basically important aspects how the machine and its other supporting machines will operate in that particular space. So, the operating space has to be provided. First is for the shovel operation. For shovel operations, we have to give the space as the area to be provided depending on the dimension of the shovel, including the radius considering the boom length. So, whatever area is available considering the boom length as the radius, that must be free, and no machine, nothing will be placed, manpower will be placed there, so that they will not pose any safety hazard in the operations of the shovel. Only the dumper which is being loaded by the excavator has to be placed in this, rest all other machineries has to be placed outside this operating space. Okay. So, this is the operating space of the shovel has to be placed there while we are designing the pit. Second is that the waiting dumpers. The next dumper which has to be take the load, if the one dumper is under loading, then the waiting space of that dumper has to be provided in that particular case. So, this is the two thing, and third is that we have to minimize the swing requirement, because more angle swinging, if a shovel is swinging this angle and again returning back this angle. So, this is the time required for swinging, but instead of that, if the shovel is swinging only this much, then the swing requirement is less if this is swinging this much. So, swinging must be close to 90 degree is assumed, but it can be up to 180 degree also. So, 180 degree means we are going for the additional swinging, which is unwanted, we can restrict it to 90 degree swinging also. So, we will try to make it as close to as 90 degree swinging, that is also the third objective. So, these are the objectives of designing a pit layout. So, this is a rectangular pit, you can see if the pit is moving, if a pit is moving this way, the pit has to move in this way, we provide an excavation at this position, then gradually throwing this one at this. So, what is the benefit? The benefit is that our shovel has to swing only 90 degree in this case, that is the benefit in this way. So, when it is reaching up to this, we will do the same thing at this position and we will extend this gradually at this in the direction. So, this is the way we carry out our extension of the pit. See, this is one by one in detail it is given. Suppose this is the pit where the excavation is made, we have to extend this. So, what we will do? We will try to excavate this part, we will try to excavate this part first, and to excavate this one, what we need to do? We have to carry out our drilling. So, these are the drill holes, we have carried out drilling at this position, then we go for blasting this one. So, after drilling we have blasted this one. So, this is basically the blasted rock mass. This is actually shown as the ramp, but this is the blasted rock mass. So, we have provided the blasted rock mass here, and after blasting this one we have deployed our excavator to take that material. So, now the excavator is working here and we are taking the material, we are allowing our dumper to stand on this and the material is loaded onto the dumper. So, gradually dumpers are taking the material and moving out from this. This is the ramp, it is provided at this position. So, excavation is carried out here and the material is taken out from this ramp from this to this direction. So, this is the way we are basically moving with our layout. This is when the two shovels are working, and this is the typical layout we have already seen, which is possible in case of the stripping shovels. Stripping shovels are working at this position, it is swinging and dumping the material in this dump pit at this position. So, this is the operation of stripping shovel. You can see this is the pit layouts. So, the plan views, these are the slope, high wall slope, and this portion the blasting is carried out. So, this is the loose blasted rock mass and this is the future drilling is carried out at this position. So, you can say this is the pit wall and this is the waste dump pit. Which is being dumped by the stripping shovel in this case. Now, let us go for calculation of cost. This system calculation of cost system is more or less same as we have practiced in case of a drilling machine. So, you know the first let us look into the problem. Say this is the same problem for which we have carried out the performance analysis. So, this is say a coal mine is planning to excavate 40 million tons of coal with stripping ratio of 3 meter cube per ton. In situ specific gravity is 2.5, 1.2 swelling factor. For overburden, we are only considering overburden, we are not considering coal in this case. So, overburden specific gravity is given, swelling factor is given, bucket fill factor is given and overburden shovel bucket capacity is also given. This is shovel cycle time is considered 2 minutes and available loading hour is considered as 4000 hour per year. The price of shovel is considered as 100 crores rupees. So, you can say it is 1000 million rupees and life is considered 50,000 hours. Diesel consumption is considered as 900 liter per hour and diesel price is considered 100 rupees. 2 manpower is required with EMS of earning per man shift is this one and effective 6 hours are available in a shift. And this is the considerations given here and we have to find out what is the cost of excavation in rupees per meter cube. Okay. So, this is the consideration. Now, you know as per the requirement we have to find out the first one is the owning cost. Second one is the maintenance cost. Third one is the operating cost. fourth one is the manpower cost, and fifth one is the overhead cost. Now, we have simplified a lot for solving this problem. We are not considering most of the other required, like say depreciation, interest, all these components are not considered here to make it simplified. So, let us consider the simple way of considering the owning cost. So, owning cost is the price by life, we have considered here the simplest way. So, this is 1000 into 10 to the power 6 rupees divided by life is 5 into 10 to the power 3 hours. So, that means it is coming close to rupees 2 lakhs. Okay. Sorry, it is not this one. So, this is 20,000 rupees, this is 50,000. Okay. 50 into 10 to the power 3. So, this is coming 20,000 rupees per hour. So, this is all are in rupees per hour. Okay. Now, maintenance cost, let us again simplify it. Let us consider this is 20% of 1. So, that is 20 into 10 to the power 3 into 0.2. So, it is coming 4,000 rupees. Now, operating cost. So, we are not considering any big consumables. The shovel bucket teeth is a very frequent consumables in a shovel operations, and in case of hydraulic shovels etc., generally hydraulic is considered separately, because hydraulic consumptions are becoming more. Lubricants are also considered as the operating cost, but let us ignore all those things for this calculation. We can have that in actual practice, but for this calculation tutorial let us ignore those things. Let us consider only the diesel consumption. It is seen that the diesel consumption is 900 liter per hour and the price is 100 rupees. So, this is 900. So, this is rupees per hour is the operating cost. So, 90,000, I think it is 90,000, 1, 2, 3, 4, 90,000 rupees per hour. And the manpower cost, we are also having some manpower cost here. We have seen that 2 into 4,000 is the earning per man shift, and it is considered that the in a shift 6 hour is the operating hours. So, our manpower cost, let us consider 4 into 4,000 into 2 divided by 6, whatever is coming, that is considered as the manpower cost. So, 1333 rupees per hour. So, all are rupees per hour, and overall cost is the sum of all this one. So, sum of is considered as the 0.1 multiplied by sum of 1 to 4. So, sum of 1 to 4 is 20,000 plus 4,000, 24,000 plus 90,000. So, that is 11. So, this is 333 is already there. So, this is 4 plus 1 5 and 9 plus 2 11. So, this is the 1,15,033, the 10% of this. So, that is at the rate 0.1. So, that is 11,533 is the overhead cost. So, altogether it is coming I think we may have some calculation mistakes here also. Okay. So, this is 11,000 something it is coming, that is rupees per hour. Now, let us look into the production per hour. Our production is that 42 meter cube shovel. It is having production of 42 meter cube into I think bucket fill factor is 0.8. So, this is the meter cube filled by one bucket, and our in situ volume is being swelled by 1.2 times. So, if we are considering the meter cube, then the actual meter cube which is being handled by this in situ, then it is divided by this. So, it is coming around 28 meter cube, in situ meter cube, which is coming in situ meter cube, 28 meter cube, that is coming in one bucket. And we have considered this is being handled in 2 minutes. So, in 60 minutes we have to multiply 28 into 60 by 2, that is 30. So, 28 into 30 is the excavation. So, whichever is coming, that is the meter cube per hour is the excavation. So, we have already calculated the cost. So, let us, to avoid any calculation mistake here, let us find out the values at this position. So, you can see the owning cost is coming 20,000 as we have found, that is 1000 into 10 to the power 6 divided by 50 into 10 to the power 3. So, that is coming, this is 20% of this one. So, that is 4000. Manpower cost is calculated, let us show it here, 2 into 4000, this is for 8 hours, this is for 6 hours divided by 6. So, this is coming to this. So, subtotal is this one. I think we have missed here, the fuel cost is missed probably. So, you have to add fuel cost at this position. So, that is 90,000 has to be added here. So, this is 90,000 which is missed here. So, again that 10% of that is 9,000 missed here. So, this will come, this will become plus 99,000. So, altogether it will be 866 plus so 127,000 you can say. So, shovel is handling 840 meter cube, as we have found 28 into I think 30. So, 28 into 30 is coming 840 meter cube. So, 126 866 divided by 840. So, this is the amount has to become. So, there is some calculation mistakes. So, let us overcome this. So, it is coming around close to you can say 140 rupees. So, 140 rupees per meter cube will be the handling cost for this, and you can see the main component is basically coming for the fuel. So, the fuel price is almost coming around 100 rupees per ton for this operation of this 42 meter cube shovel. So, this is the way you can carry out cost calculations. There are other components, which are required to be incorporated in this calculation, that is interest part. The reason is that, say if the Sobel price is 10 to the power 6, the investors must have to take the loan from this, and that is why interest has to be paid, and in this case most of the cases this interest rates are close to 12% or so. So, this is significant amount has to be incorporated there. And second is that the depreciation of the machine also need to be considered, because that component must be added at this position. So, these two are the part of the owning cost that has to be incorporated. Second is that we have seen the main component is the fuel, which is coming around say 1 lakh rupees, and in general the 5% of the fuel cost is considered as the lubricant cost. So, that is also significant one. So, 5,000 rupees has to be added for that. So, these are the significant amount has to be added in case of actual cost calculation part, and so the costing will be very high for using this high power machines. Their operating costs are very high and their owning costs are also very high. So, this is the way the cost calculation can be carried out for the Sobel operations, and we will continue the transportation system, Sobel operation and transportation system combinations with the following classes. Thank you.